Morning students, we will start our fourth video, okay, of chapter 1. So today we will discuss about couple. So in the previous video we have already discussed about the moment of force, clockwise and anti-clockwise moments, and the unit of force both in our absolute units as well as in gravitational units, okay. So by heart them. So now today we will study about our couple, COUPLE. Okay, so this is related to our torque, that is moment of force. Okay, so uh, its definition will be couple. Okay, so the two equal and opposite force acting on a rigid body such that they act along different line of action of force constitute a couple. That means suppose there is one example or in page number 4, figure number 1.9, you can see that there is one nut. Okay, so to open this nut, if we apply a torque or moment of force along clockwise or anti-clockwise direction, it will require more force. But if we apply equal and opposite force but in the different direction, then it will be easier to open the nut. Okay, so if we give the definition, so what is couple? It is the two equal and opposite forces, acting on a rigid body. Rigid body is already discussed, such that they means the two forces, they act along different lines of action of force, different lines of action of force. Okay, and this constitute our couple. So this constitutes a couple. So you can see the figure in page number 4, that is figure 1.9. so we have applied two different forces. You can see the direction of the force. Okay, so there is one nut holder here also, and this is the arm. There is one nut holder, and similarly we have another nut holder here in which the nut was fixed, and there is another nut holder. So if we apply a force in this direction and we apply the same magnitude of force in this direction, then it will be easier. So if we apply this force, it will rotate in this way. Okay, and if we apply the force, and the rotation for this force will be in this direction, that means it will move in anti-clockwise direction. Okay, so this constitutes our couple. And if you see the mathematical formula of couple, so this will be our the force, the magnitude of the force. Okay, the magnitude of the force into the arm of couple. So which will be the arm of couple? We have applied the force in this direction here, and we have applied another force in this direction. Okay, so this line will be the arm of force. Okay, or we can say this will be the arm of couple. This line will be the arm of couple. So we can see another example in figure 1.10. Okay, suppose we have one rigid body like this. Okay, and suppose it turns about this point and it rotates about this point O. So if we draw a line of action of force, this will be the line of action of force. Suppose we have, okay, fine. So we have taken two axes, so we have applied a force in this direction, and again we have applied another force in this direction. Okay, so then we have applied two equal and opposite force in different directions. So this will rotate about the this will rotate about the turning point O. So which will be the arm of couple? This will be the this length, that is A to B. This length will be known as our arm of couple. Fine. And this O is our turning point, and this dotted line will represent the line of action of force. So if we see the mathematical formula of moment of force, or mathematical expression for moment of force, sorry, not moment of force, moment of couple. So its answer will be that moment of couple is equals to force, the magnitude of the force, into arm of couple. Okay, so in the previous video we have considered this. Suppose this is the two line, we have applied the two forces F and F both in the opposite direction. Its turning point was O, and this is the line and joining, or if we can say the line of action of force. This distance AB, this AB will be the your arm of couple. So from this figure we can say the force is F into the arm of couple, that is arm of couple will be our AB. Okay, so we can see the rotation. So if we see this figure, our rotation is likewise. Okay, rotation was like this one, that is clockwise direction. So AB in clockwise direction, so you can write CWD, clockwise direction. Fine, we can do it in the anti-clockwise direction also. Okay. Now our next topic will be the what will be the unit of couple. Unit of couple. So the couple, you can see there is two quantities, that is force into the length. Length means that is arm of the couple. We need the length. Okay. Fine. As in moment of force also, our formula was moment of force was force into the perpendicular direction. So here also perpendicular distance. Okay, so here also in moment of couple we have force multiplied by AB, that is a distance. So in moment of force also we have force into distance, and in case of moment of couple we have also force multiplied with the distance. So the units will be same. Okay, so the unit of couple is same as unit of moment of force. Both will be same. So you have to write them all in absolute unit as well as in gravitational unit. Okay, both will be same. Again, in absolute unit you have to write the CGS system as well as MKS system, and also in gravitational unit you have to write the units in MKS system as well as in gravitational system. Fine. So you can see some examples in page number 5. The first one is your opening or closing of the tap water. So we use both the hands to open or close the water tap. Okay, and similarly to open or close the screwdriver, generally we use single hand or double hand. Okay, then to loosening the cap of the ink bottle also, or turning of the key, or the rotating the steering wheel of a motor car. So you can see that. Okay. Our next topic is equilibrium of bodies. Equilibrium of bodies. So we say that a body is in equilibrium if the sum of all the forces acting on that body is zero. Okay, if the sum of all the forces acting on that body is 0, then we will say that body is in equilibrium. That means if a body is moving, then it will be in the state of its motion, or if the body is in rest, then it will stay in rest. Okay, so if we see the definition of equilibrium, so when a number of forces, it may be two or more than two forces acting on a rigid body such that it does not change its state of rest or motion, then that rigid body is said to be in equilibrium. Okay, so you write the definition of equilibrium. Okay, so you write it. Okay, this will be homework, page number 5. Okay, so you have to write it, the second paragraph. Then we have the different kinds of equilibrium. So I will discuss it in the next slide. Kinds of equilibrium. So our first is static. Static equilibrium. Static means it is the position of rest. Okay, so when a body remains in its position or state of rest when two or more forces are acting on it, it means the body, then the body is said to be in static equilibrium. Then, or the body is said to be in static equilibrium. That means suppose a body remains in rest if we apply more than two forces. Okay, two or more than two forces. After application of that forces, and if the body remains in rest, then that equilibrium of the body will be said to be our static equilibrium. Okay, so we can say see some examples. Okay, in figure number 1.17, page number 6. Okay, so it is written that figure 1.17 shows a block of wood. Block of wood means suppose one heavy piece of wood is on any floor, okay, placed on the top of the table, such that Fa is the force applied on it. Fa, okay, you can see the force applied on the block. And its direction is also given, but it does not move. Because why it will not move? Because the weight of the block is so heavy such that if we apply the force, it resists that force. Okay, because of the force of friction, because force of friction is greater than the applied force, and that's why the body is in rest. So if we apply a force greater than the frictional force, then only that body will move. Okay, now again, if we apply another force Fb of equal magnitude, which was applied before, that is Fa of equal magnitude, but in the opposite direction, the body will be in rest. Furthermore, the weight of the block, that is W, which is acting downward, acts vertically downward, and this weight balances the normal reaction, okay, by the tabletop. So as all the forces cancel out, how cancel out? We have applied a force Fa and Fb, but though both are in opposite direction, that's why that two are cancel out, because that are in opposite direction and their magnitude are same. Whereas the weight of the body W is balanced by the normal reaction. So the capital R, that is normal reaction, and the weight of the block, that is W, these are also of the same magnitude but in the opposite direction. So this also cancel out, and that means all the forces acting on that block cancel out, or we can say the sum of all the forces acting on that block is 0. That's why the body is in rest. So this type of example is known as static equilibrium. Okay. So you can see the second example, figure number 1.8. So read that. Okay. So if you find any problem, then you can directly contact me. Fine. So next type of equilibrium is our dynamic equilibrium. Dynamic equilibrium. Okay. So what is dynamic equilibrium? It will be the in case of motion. Okay. All will be same when a body remains in its uniform state of motion. Either it may be translation motion or it may be rotational motion. When two or more forces acting on it, then that state or that equilibrium of the body is known as dynamic equilibrium. So you write this definition from the book, page number 6. Okay. So you write it. This will be your homework. Fine. So for the dynamic equilibrium, we have 3 examples. So if we see example number 2, that is a train running with a constant speed is a dynamic equilibrium. So in exam, question may be asked. So give an example of a dynamic equilibrium and explain it. So you can write any of the example given in the book 1, 2 and 3, or you can make on your own. Okay. So if you see the example number 2, it is written that a train moving or running with a constant speed is a dynamic equilibrium. Why? Because the forces generated by its engine is equal to the force of friction due to rails and force of the friction due to air. Both are equal. That means if the train is moving, it will continue in motion, continue in its state of motion, or if the train is in rest, then it will tends to be at rest. Okay. So similarly, you can see the example number 1 and 3 also. Okay. Now we have our condition for equilibrium. Okay. We have already discussed. You can summarize this. Okay. Condition of not of condition for equilibrium. So we have 2 condition for equilibrium. So I will discuss this. You have to write it. Okay. Write it from book. Okay. Page number will be 6. So the first condition will be that the resultant means the sum of all the forces. It may be translation force or the rotational force acting on that body should be 0. And the second condition is that the result of movement of force. Resultant of movement of force. First one is the resultant of all the forces, and second one is the resultant of all the moment of force of the rotational forces acting on the rigid body around the turning point or the axis of rotation should be 0. Or in short, you can write that all the clockwise movement should be equal to all the anti-clockwise movement. So if you don't want to write the second point from the first sentence, second sentence, third sentence, then you can continue from the fourth sentence, that is the clockwise movement should be equal to the anti-clockwise movement. Then only we will say that the body is in equilibrium. Fine. And the first one is the resultant of all the translation force acting on the body should be 0. So write all the 2 points. Okay. So in the next video we will continue the principle of movements. So it will take more 2 lectures. After that we can complete our chapter and we can discuss the exercise. Okay. Okay. Thank you.